Hello and welcome to SudoKanard. This puzzle is called Ascending Starter Sudoku. It was featured as the highest pointer puzzle in the Dutch round of WPF Sudoku Grand Prix in 2022, and I think it was overvalued. The puzzle is very good, but it's not that difficult to be worth 90 points once you've had the proper training. And the puzzle that I created was much more difficult than that, but it would have been too difficult for Grand Prix, certainly. So the special rule is that the numbers outside the grid are the sums of the first few digits, and we sum the digits while they increase. For example, we could have 2, 4, 5, and then 3, and the ascending streak is 2, 4, 5, which sum to 11. So where do we start? Well, 2 is a valid start. The only way to add digits so that the sum is 2 is to just put a 2 here. And because the ascending streak stops there, we must put a 1 behind it. And now the only way to sum to 4 is to put a 4 here. And we must stop the ascending streak, so that can only be a 3. So that was an easy start. And now there's the question, what about this 23? If you're familiar with Tira Sudoku or with Kakuro, you know that 23 is very useful when it's the sum of only 3 digits. In this case, this is 6 plus 8 plus 9. But you see that 9 can't work with this 11 cube, because then the ascending streak stops here, and the sum is 9, not 11. Which means that the ascending streak must go past the 3rd digit. So this is ascending. We already have 10. We need 13 more, and there are 2 ways of achieving this. One way is 5 plus 8. The only way is 6 plus 7, sorry. But then if you try to put a 6 here, well, 6 is not 11. That's a knowledge bomb from SudoKanard. But how do you work your way up to 11? By adding a 5, that's not working your way up, but working your way down. So this is not correct. This has to be a 5, and this has to be 8. Now to get to 17 by increasing, you must put a 9 here. And to get to 11 by increasing, you must put a 6 here. And this is the only way of achieving all those cubes. Now, we must have 1, 2, and 7 here. This must be 7. Those must be 1 and 2. And here we need 6, 7, and 9. But 9 is not here, because then the sum would be 32 and not 23. So that's a neat start. Let's see about this. Digit 6 is no more available, so we must have ascending digits. It won't be 1, 2, 3, so it will be either 1, 5 or 2, 4. And remember that this digit must be smaller than this one, which means it's from 1, 2, and 4. Now, what about this 13? We must have at least 2 ascending digits. We could have as many as 3, except that if we put 3 digits here, actually, this would seem to work. We must have the 3 somewhere. Could we have the 3 and 2 digits summing? No, actually, sorry about that. We must have the 1 and 2 are not available here, so we must have a 1, 2 pair in here. So here we must have 3, 8, and a digit from 4 and 5. The only way to sum to 13 is to have 5 and 8. That's the only way. 3 can't take any part in this. So that's a 4, that's a 2, I said, and that's a 1. So all of this is now fulfilled. Here, summing to 11, we could add 8, but actually nothing else is possible because ascending digits adding up to 8, starting from 4 or more, 8 is the only possibility. Here we have 5 and 7. And here we have 4, 6, and 9. But 9 here doesn't work because the ascending streak must stop here. What about this? I need to ascend at least one more digit, so that can't be a 4. But if I try to put a 6 here with a 5, I get to 12 and I need another 5, which is not possible by increasing. So that's the 9 here. And 9 obviously stops the increasing sorry about that, the increasing trend, and the only way to get to 17 is to put a 7 in here. And that's a 5. So all of these clues are now fulfilled. Where do we look next? Well, 26 needs at least 4 cells. I'm not sure that's the right place to look. This 5 looks interesting, I think. This 21, I don't remember where I did look at the time. So this 5, it can't start with a 1, but it could still be 2, 3, and 1. It could still be a 5 here. Those are the only options. And in one case, this is a 3, and in the other case, if this is a 5, then this must be from 1, 3, and 4. So where else should we look? 11. Could it be with 3 cells? I don't think it could. For example, 2, 4, 5 doesn't work. There's no more option for this. 2, 3, 6 would seem to work with a 5 here. Actually, it does work. So that doesn't seem to be the right place to look. 21, perhaps. Mm, 21. Alright, so how many digits do I need? It could seem to be 4, 8, and 9, for example, with 1, 2, 3, and 7 in here. That seems to work. It could probably be more than that. I don't remember having such hesitations at the time, but what am I missing? This 16 perhaps. This is at least 3. Yes, that's it. If I try to get 4 digits into this sum, then the minimum value is 18. So that's not the case. 2 digits is not possible because it would have to be 7 and 9, and 9 is not available. So this is 3 digits. What are the options? If I try to start with a 3, I need another 13, and actually 6 and 7 work, or seem to work at least. So that seems to be a valid option. If I start with a 5, I need another 13, another 12, which means 5 and 7, so this is 7 anyway. So that's interesting. So we have this. Okay, I think. So that's either 4, 5, 7 or 3, 6, 7. So here this 21. Interesting part here is that 3 and 4 are forbidden from here, so the second digit that is 3 or 4 must be here, and obviously it must be in first position. So with 4 we could go with 8 and 9, and actually 5 and 6, they are both excluded from here, so the counterpart of 5 and 6 is here, so it's here. And those must be 8 and 9 ascending, and to get to 21, that's a 4, that's a 3, that's a 6 to get to 16, and that's a 5, which means that this can't be 5 anymore, that's a 2, that's a 3, and the ascending streak stops here, so that's a 1. Really nice. I had completely forgotten about this part, but this works very well. Now, where should I look next? Here I need 4, 6, and 8, so that's a 6. I get a 4, 8 pair here. So about this 13, the interesting fact here is that all high even digits have been taken. Actually, all even digits have been taken. So 13 must be done with only odd digits. And the only way of achieving this is to have 1s, 5, and 7. No, actually, it could have been 3 and 9, but 3 is not available. And now this 12. Here I need 2, 3, and 9. So 9 won't work here. It will make a sum of 10. 3 is not available here. So how... Oh, this can't be a 2, sorry. So that's a 3. I need another 8, and with a 4 it wouldn't work. So that's 4, that's 8. All right. Here I need 4, 7, and 5. So the only way to sum to 11 is to have 4, 7, and 5 in this order. Here I need 6, 7, and 9. 6, 8, and 9, sorry, that's not 8, that's not 9. This 7 disambiguates this. And then what? What could this be? So this is at least 4, and 4 and 5 is not available because this 5. So I can't have this made to be the sum of 2 or more digits, so it's a single one. With 7 and 9 there, that's not a 9. Here I need a 4 and a 6. But 6 here wouldn't work. The minimum value would be 6 and 8, which is 21. So that's a 4, that's a 6, and obviously 19 is not the sum of just 2 digits. Now I need another 15. Well, with 5, 6, 7 that would be too big, so only 2 digits will have to do the trick, and actually the only way is with 7 and 8. Oh, which a 9 pair is resolved. That's 1, 3 pair, that's a 2, 5 pair. That's not big. So we're just left with the 26 and the 12. 26 needs at least 4 digits. And it would actually work with 5, 6, 7, and 8, which is a well-known sum for Kakuro users, for Kakuro solvers. But could it be more than that? Could it use 6 digits? If I put 6 digits in the 26, then we get to 35, and those two would have to sum to 10, which is not possible. But if I try to make 26 here, would it work? Actually, this, I could just look. I remember that it was with 4 digits. Maybe it's not the right place to look. What about this cell Here I need 1, 2, 4, and 5. So this is 1, 2, 5. 1, 2, 4, 5. Oh, I know. If this were a sum of 5 ascending digits, then this would be 8. And 8 is not available. So it must be the sum of 4 digits and not using the 9. The only way is to have 5, 6, 7, and 8. So that's the correct way of looking at this. That's a 5. 4 can only be here. That's 1 or 3. That's a 4, that's a 6. Down there, that's a 9. That's 8, that's 6. Here I need 3 and 8. Here I need 2 and 4. Here I need 1 and 9. And this 12 clue was not needed. Here I need 1 and 5, so that's 1, that's 5. 3, 1, 3, 2, 1, 2 here, and 7 there. And it didn't trigger, which is really ominous. I must have mistyped something. Well, I just have a look at my solution. So I'm back with the paper. This is the puzzle that I solved. This is the pointing digits puzzle that I failed to solve. All right, so what am I looking at? The first 2 rows are correct. This all seems to work. Sorry, this is really not interesting to see me do that. All right, I agree completely with what is on that paper. So I must just have forgotten to put the answer check when I created the pen-pal interface. Or perhaps I typed a wrong digit into it, which is something I'm perfectly able to do. Well, that was really a nice puzzle, and I suspect it was by the professor Richard Stolk. I must ask him how to pronounce his name one day, because I solve his puzzles quite often, and I would like to pronounce his name properly. So anyway, thanks for watching this video, and see you soon on SudoKanard.